Every page of the company site is returning the same 3 digits. 502, bad gateway, monitoring is red. Customers are emailing, and you are holding the pager. Don't worry. By the end of this case, you will know exactly what 502 means, what every command we type does, and how to hunt this down calmly. Let's go. Before we touch anything, a quick question. The site says 502, where do you look first? Pause if you need to. Lock one in, we will prove the answer together. Rule 1, never debug from a screenshot. See the failure with your own eyes. We use curl, the tool that fetches a web page from the command line. -s makes it quiet, no progress bar. -i means also show me the response headers, the top part of the reply. And we pipe to head -2 to keep just the first 2 lines. There it is. 502 bad gateway, and look at the second line. The reply is signed. Server Nginx. Hold that thought. Everyone's first suspect is the web server, so let's ask about it. Systemctl status, then the service name Nginx. -- no - pager just means print it straight to the screen, don't open a scroller. And the answer? Active, running. The web server is alive and feeling fine. And here is the reflex everyone reaches for. Just restart it. No error, feels productive. But did it actually help? Let's check properly. This time we ask curl for one thing only. -o/dev/null throws away the page body, and -w right out prints just the value we name. Here, the HTTP code. The answer, 502. The restart changed nothing. Time to stop guessing and start thinking. Let's picture the setup, because it is the same on most of the internet. Your browser never talks to the application directly. It talks to Nginx, sitting at the front on port 80. Nginx then passes the request to the real application, running quietly in the background on port 8000. Nginx carries the answer back to the browser. That is a reverse proxy. Think of it as a receptionist for your servers. So 502 has a precise meaning. The receptionist is saying, I am fine, but the office behind me did not give me a usable answer. That is why the error page was signed by Nginx. Nginx wrote it about somebody else. The service behind the proxy has a name. The upstream, that is the word to remember. And the upstream, not Nginx, is exactly where we are going to hunt. So if an interviewer asks what a 502 really means, this is your one line. The proxy is fine. The upstream is not. Nginx keeps a diary. Its error log. Tail-2 shows the last 2 lines of any file, and there, while reading the response from the upstream, the connection broke. Nginx is innocent. It has been telling us who the real problem is the whole time. Now ask systemd a simple question. List me everything that has failed, and there is our victim. Orders-API, that is the application sitting behind the proxy. It is down. Look closer at it. Status, failed. Exit code 1, the service did not stop politely, it crashed. So like before, we just started again. No complaints. Systemd says done, case closed, watch very closely. Give it a few seconds, then ask again is -active. Failed, it started and then it died. Remember this line. A service that starts and then dies is not a starting problem. It is a crashing problem, and crashes always leave fingerprints. One layer down, Nginx was innocent, the app is the victim, but the restart will not stick. Somebody is blocking it. To find out who, we need the service's own diary. Meet journal.ctl. On a modern Linux box, it is the one logbook that holds what every service has said. -u then a name filters it down to just one unit, one service. Here, orders-API. -n then a number gives you only the most recent lines. We want the last 6. And -o cat strips the timestamps and host names, leaving just the message. Clean, let's read it. There is the fingerprint. Connection in use. Address already in use. When our app tried to grab port 8000, the port was already taken. By what? Let's go find the squatter. The tool is SS, Socket Statistics. It shows the network connections a machine has open. We stack 4 short flags. -L, only sockets that are listening, waiting for traffic. -T, only TCP. -N, show numbers, don't translate port 8000 into a name. And the important one, -P, tell me which process owns the socket. That is how we name our squatter. We add a filter, source port equals 8000, and look, port 8000 belongs to a plain Python process, but systemd just told us our service is dead, so this is somebody else. Let's confirm with a second witness. LSOF lists open files, and on Linux, a network socket counts as a file. -I picks the network ones. It agrees. A Python process holds 8000. 2 tools, 1 story. So who exactly are you? The part in brackets pulls the process ID straight from SS. Then PS prints that process's full command line. And look at the path. A release directory from weeks ago. This is a ghost, an old copy of the app that never died during some past deploy. It squats on the port, answers nothing, and blocks every restart. Evict it, kill with no other flag sends the polite signal. It means, please finish up and exit. No output means it worked. Ask SS one more time. Silence. Nothing is listening on 8000 anymore. The port is finally free. Start the service. Wait for it, and failed. Again, don't be discouraged, this is completely normal. Real incidents are like onions. You peel one layer and the next one is waiting underneath. But notice, the fingerprint will be different this time. The port is free, and the app still dies on its own. We are one fingerprint away from the real root cause. Back to the logbook. Same journal.ctl, but this time we search it. The reason has changed. There it is, key error db_host, in plain words. The app asked its environment for the database address, and it simply was not there. It even prints the exact line of code that needs it, so the app refused to start half-blind. Honestly, good app. Here is the environment file the service reads on startup. Read the names slowly. There is a database_host, but the code asked for db_host. Close, and completely wrong. Want proof of where it came from? grep pulls the host line from 2 releases at once, the one that worked and the one that just shipped. There is the crime. The new release renamed the variable and nobody updated the code. The deploy did it. To fix it in one move, we use sed, the stream editor. It edits text by a rule. The rule is s/old/new/. Substitute the old text with the new text. And -I means change the file itself in place instead of just printing the result. One careful command. So we substitute database_host back to db_host. And to be clear, this is the hot fix to stop the bleeding. The real fix also goes into the deploy pipeline, or the next release breaks it all over again. Never trust an edit you did not reread. Grep it. db_host is back. Third start, stay up. Active, and this time it holds. Now the only test that truly counts. From the front door, exactly like a real user would. 200. The site is back. And one last look at the full answer. The order's a PI is up, talking to its database. Status, okay, breathe. Now let's lock in what this incident taught you. This trap bit us twice, so burn it in. When systemd says started, it only means the process was launched. It can still crash 1 second later, and systemd will not shout about it. So after every start, ask again, is -active? One word comes back, active or failed. That word is the current truth, not the launch report. And when the truth is failed, never guess. Journal.ctl-u, the service's diary, always holds the reason. Read it top down, find the last error, take your next step. Playbook, 502 means the proxy is fine and the upstream is not. Start behind the proxy. Confirm it in 30 seconds. The service status plus the Nginx error log. If the service cannot bind its port, SS names the squatter. Then evict it politely. If it starts and then dies, the journal holds the crash reason. Read it before you change anything. And you are only done when the front door answers 200. Verify like a user, not like an admin. Here is what the senior writes afterwards. The 502 was one symptom, sitting on 3 stacked causes. A deploy renamed an environment variable. The crash then looked like a simple restart problem. And underneath, a ghost process from an old release was holding the port. And remember the receptionist. That is all a 502 ever means. The receptionist is fine, but the office behind it is not. Real incidents are onions. Peel them one layer at a time. Prove every layer with a command, not a feeling. And never call it fixed until the front door says 200. That answer, in an interview, is what separates a senior from a junior. Case number 1, closed. If you want to stay this calm when the pager goes off, subscribe. The next case is already waiting, and it starts with every customer seeing a security warning.